Good morning, everybody. Welcome to my physics class. How are you? Hope you are fine. Today, I will deliver my lecture for Standard 9. Today's topic, flotation and immersion of a body, and I will also explain Pascal's law. How can a body float on water, or how can a body sink into the water? There are some causes behind this. I have explained buoyancy in the previous lecture. So I think buoyancy is clear to you. Due to buoyancy, an object can float, an object can sink into the water, or an object can be floating in fully immersed condition. Look at these two figures. Here we can see an object is floating on water, and here we can see an object is sinking into the water. Okay, so the reason for sinking or floating is that buoyant force. So when buoyant force is greater than the weight of the object, then the object can float on water. But here we can see the object is sinking. That means here buoyant force is less than that of the weight of the object. That means the weight of the object is greater than that of the buoyant force. That's why the object is sinking. There are some cause or condition which are responsible for the flotation and immersion of a body. Look at this figure, everybody. Here an object is immersed in water at rest. So here two forces are act simultaneously on this object. One is the weight of the object, which is acting vertically downward, and another one is the buoyant force that is acting vertically upward. Okay, so the conditions for flotation and immersion of the body are number one, if W1 is greater than W2, that means weight of the object is greater than the buoyant force. Then what happens? Then the object will sink into the liquid. In this case, the weight of the body is more than the weight of the displaced liquid. You know, if any object is immersed in water, then it will displace some amount of water equal to its volume. So the weight of the displaced water equal to buoyancy. So when the weight of the object is greater than the weight of the displaced water, that means the buoyancy, then the object will sink into the liquid. Number 2, here we can see W1 equal to W2. That means weight of the object and the buoyancy or the weight of the displaced water equal. Then what happens? Then the body floats being fully immersed in liquid, which I am showing here. Okay, you can also see, I think you know about submarine. Submarine can float in fully immersed condition. So when the weight of the object and the buoyant force are equal to each other, then the object will neither float on water or nor it goes down at the bottom. It will float in fully immersed condition. Number 3 condition, W1 is less than W2. W1 means the weight of the object and W2 means the buoyancy or the buoyant force. That means the weight of the displaced water. So if weight of the object is less than that of the weight of the displaced water, then the body can be floating on water being partially immersed in the liquid. In such case the weight of the body is less than that of the displaced water. That for an example, I can tell about ship. A ship can float on the sea, being partially immersed in water. Here, the weight of the displaced water by the ship is more than that of the weight of the ship. That's why it can float on water. Look at this figure. In this figure, we can see an object is floating on water, being partially immersed. That means a portion of the object is in immersed condition in the liquid. So here, which condition will be applied? That means here the buoyant force is greater than that of the weight of the object. Here we can see the object is at the bottom of the water. That means the object is sinking in the liquid. So here weight of the object is greater than that of the buoyant force. But here the object floats being fully immersed in the liquid. That means weight and the buoyant force are equal to each other in this case. Again, I want to summarize. So buoyant force and flotation. If buoyant force equal to weight of the object floats and stationary, being immersed in water. Buoyant force is greater than weight, then the object moves up. Look at the ship. Buoyant force is less than the weight, then the object moves down. Look at here. Here I have given one picture. You can see a person is reading a newspaper being floating on the water. He is not sinking. Why? Because the density, this is the picture of Dead Sea, and you have to know one thing, the density of water of the Dead Sea is the highest because it is too much salty. And buoyancy equal to what? Buoyancy, the formula for buoyancy is V rho G. Buoyancy equal to V rho G. Here rho is the density of the liquid or water. So as the density is greater, so the buoyant force is greater here. That's why any person can even sleep on the sea on the water of the Dead Sea. Now I will explain Pascal's law. If pressure is applied on any point on an enclosed liquid or gas, it is transmitted in all directions. Pascal stated a law about this transmission of pressure. This is Pascal's law. You have to memorize this law because in your exam for 1 mark question, this type of law can be given to state. The law states here, external pressure applied to any portion of a liquid or a gas enclosed in a container. You know, a liquid or gas cannot be kept without any container. So here I am telling you each and every point of this law, Pascal's law, you have to understand properly, because if you don't understand without clearing the concept, you will not understand the physics. So external pressure applied to any portion of a liquid or gas enclosed in a container is equally transmitted in all directions in the liquid or the gas without any trace of diminution. That means there will be no loss of the pressure and acts perpendicularly on the surface of the container in contact with the liquid or gas. Look at this figure. Here, some water is enclosed in a plastic ball or in a balloon. You can tell about balloon. And an external pressure is applied by using the thumb. Then, then the pressure will be equally transmitted in all the direction. Okay. So if I make some pour on the balloon, then the water will come through all the pores with equal pressure. So which supports Pascal's law. That means pressure applied on any point of liquid transmitted equally in all direction. Application of Pascal's law. This is an interesting example of Pascal's law, which shows us that how force is multiplied. Okay, look here. This is a U-shaped body. There are two cylinders, C1 and C2, and that is connected with another pipe here. So this is an U-shaped pattern. There are two pistons which are flexible and movable in the cylinder and also leak free. Here is the piston 1 whose cross-sectional area is A1, and here is the piston 2 whose cross-sectional area is A2. You can see from the figure the cross-sectional area of the piston 2 is larger than that of the cross-sectional area of the piston 1. That means A1 is less than A2. So when by this piston, a small piston, when F1 force is applied, then on the area A1, then there will be created a pressure. Pressure equal to what? You know the formula of pressure. Pressure equal to force applied perpendicularly on an unit area. So here the pressure becomes F1 by A1. So according to Pascal's law, that pressure will not be diminished at any more at all. That means there will be no loss of the pressure. Rather, the pressure will be equally transmitted through the liquid in all directions. So this pressure will be applied on this larger piston A2. For this pressure, there will be created a force F2 in the upward direction. Okay. As the cross-sectional area of A2 is larger than that of the cross-sectional area of A1, so the force will be multiplied here. So again, I am explaining this figure. I will derive the formula here. Dear students, I want to say one thing. You must write down all the derivation in your copy. If you practice the derivation, that you can understand physics more properly. Cross-section area of the smaller piston is A1. Cross-section area of the larger piston is A2. The applied force on the smaller piston is F1. Look, okay. Then the pressure applied on A1 is what? P equal to F1 by A1. Now this pressure is transmitted through the liquid in all direction, and it will also be applied on the cross-sectional area of the larger piston. That means on this piston the pressure will be applied. Therefore the force applied on the larger cylinder is what? F2. Okay, here the force is incoming force is F1, and the force F2 on the larger piston is F2. So force if P equal to F by A, then F equal to PA. That's why F2 equal to P into A2. Here you can see I kept it P, not P1 or P2, because here the pressure is the same. Pressure is constant. Pressure will not be diminished at any more. Okay, so P into that is pressure, the pressure which is applied on this piston, and the area A2, PA2. Then P, I got the formula for P is P equal to F1 by A1. If I put this in this equation, then it becomes that F1 into A2 by A1. Finally, I can get this formula F2 by F1 equal to A2 by A1. By using this formula, you can do the math that are based on Pascal's law. So, greater is the cross-sectional area of the larger piston, the Greater is the force exerted on it. Look, here the cross-sectional area of A1, this is A1 and this is A2, and you can see A2 is very greater than that of the A1. So if greater is the cross-sectional area, then greater is the force exerted on it. If the cross-sectional area of the larger one is 100 times greater than that of the smaller one, then if 1 Newton force is applied on the smaller piston, then 100 Newton force will be exerted on the larger piston. That means this is the principle of multiplication of force. Now I will show you the work done of both the piston is equal. Here in the figure you can see F1 force is applied on the smaller piston. As a result, the piston moves down by traversing a distance d1 in the downward direction. Okay, and the larger piston moves up by traversing a distance d2 in the upward direction. Okay, so let a force F1 is applied on the smaller piston and the piston moves a distance d1. So in order to move the piston by applying force F1 and for traversing a distance d1, there must be work done. So that work done equal to W1 equal to F, work equal to force into displacement. So here work done equal to W1 equal to F1 into d1. Force on the bigger piston is F2. F2 equal to, previously we have deduced that formula, F2 equal to A2 by A1 into F1. As the water displaced by smaller piston moves the larger piston by a distance d2 by pushing, therefore d1 A1 equal to d2 A2. That means d1 A1 means what? Volume. The volume of water which is displaced by the smaller piston in the downward direction, the same volume of water will move above by the larger piston. That's why volume means what? Volume equal to length into breadth into height, or you can tell volume equal to area into height. Here area is A1 and the height, that means the height of the water column that moves down is D1. So this is the volume of water which is displaced by the smaller piston, and this is the volume of water which moves up above by the larger piston. These two must be equal. Distance traveled by the larger piston is d2. Earlier I have told you the distance traveled by the smaller piston is d1 and the larger piston is d2. So from this equation we can write d2 equal to d1 by a1, d1 into a1 by a2. Just we will divide d1 a1 by a2 here. So the work done W2 on the larger piston will be what? W2. W2 equal to, work equal to force into displacement. So for the larger piston, force is F2 and the distance traveled by the larger piston is D2, F2 D2. Here, if we put the value of F2 from this equation and if we put the value of D2 from this equation, then the final result comes F1 D1. So which is proved here. That means the work done on the smaller piston is equal to the work done on the larger piston. So here both on both the piston equal work is done. You will also practice this derivation by writing in your copy. Then it will be more clear to you. Dear students, there are some examples which are made based on Pascal's law. That is hydraulic jack. It is used to lift heavy load. Hydraulic pump. Hydraulic pump, it is used to discharge fluid or liquid. hydraulic brake. Every time you see a car come to halt using this Pascal's law. Let's watch a video. Let's watch the video now.
Hello everyone. We already know about Pascal's law. But also know that
Dear students, by watching the video, I think Pascal's law and Pascal's law is clear to you. So I want to finish my lecture today. So now, you know, the spread of novel coronavirus has brought our lives to a standstill. So you should practice social isolation and self-distancing to control its spread. Stay safe and use your every moment effectively. Goodbye, everybody. So there is a moral for you. You never fail until you stop trying, by Albert Einstein.